Okay, for scan. Scan is also known as the elevator algorithm because its characteristic is just like elevator or lift. Okay, elevator is lift, right? So its characteristic is just like elevator. Okay, where it will move in one direction only. Okay, one direction. Okay, if it increasing, then it will increase. Okay, okay, it will fulfill all the requests that in increasing direction, and then it will fulfill the request of decreasing direction. Okay. Satisfies all outstanding requests until it reaches the last track in that direction, and then the direction is reversed. Okay. So basically, scan favors jobs whose requests are for tracks nearest to both innermost and outermost tracks. Okay, but does not cause starvation. Okay, this is the good thing lah. We can see here the fairness part. Okay, the fairness can be achieved. Okay, from here. Okay, so we can try to do the scan algorithm, and we have to see the condition. It mentioned here, it's in the direction of increasing track number. So if it's increasing of track number, starting from track 100, you need to increase it. Okay, you need to choose tracks that are in increasing manner, right? And then we will do the opposite, decreasing. Okay, start with increasing first. So from 100, we increase to 150. Okay, increase to 150, and then you increase to 160. Okay, increase to 180, 84. Okay, that one is towards to the end of the track. So after end of the track, okay, we go to the opposite direction. Okay, okay, meaning that below 100, right? Below 100 is 90. Okay, below 100 is 90, and then going down to 58, 55, okay, 58, 55, 39, 38, and then 18. Is it correct? 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So again, you can get the difference between these two tracks. 150 minus 100 is 50. Okay, 10. Next 24. 94. Right. This is 58. 90 minus 58 is 32. And then 3. And then 16. Okay, 39 minus 38 is 1. 38 minus 18 is 20. Right. So again, to get the total seat time, add it all up. Add this all up. You will get 250. Okay. So this is the total segment. Okay. And then if you want to get the average, okay, you have to minus it with 9 tracks. Okay, it is all not always divide with number of tracks. You can see the there are sometimes it's given to you. Okay, it's given to you. The the number of average sick time, and many other information as well. So we have to depends on that information as well. So this is the average sick length using scan. Okay, finally for C-scan, circular scan. Okay, this one restricts scanning to one direction only. Okay, one direction only. So if it's increasing, then it will fulfill all the increasing requests. If it's already at the end of the track, it will go back, it will return, and then return to the beginning of the track, and then you scan again from the beginning using the same direction, increasing. So increasing, return, and then you increase back. If it's decreasing, you decrease, return, and then decrease back. Okay, so that's the meaning of only scan using only one direction. So when the last track has been visited in one direction, the arm is returned to the opposite end of the disk, and the scan begins again. Okay? This reduces maximum delay for new requests. Okay? It will reduce maximum delay. So you can see the pattern here. So because this is increasing, okay, this is actually increasing. You see, this is 0 to 200, right? That number. So this is increasing, okay, and then it will return. Right here is it will return to the beginning, and then it will scan at the same direction. Scan at the same direction. So we shall do the scan algorithm. So for C-scan, for the C-scan algorithm, okay, again, it's in the direction of increasing track number, yeah, but with a bit different at the when it's already at the end of the track. Okay, so again, start from 100. Okay, increasing in increasing manner. So start, it will continue to track 150. After that, 160, and then 184. Okay, as it reaches the end of the track, 184, we will go back, return to the beginning of the track, okay, and then start from there. So meaning that it start from the lowest, in this case, the lowest track, which is 18. Okay, 18. So 18 increase to 38, and then increase to 39, increase to 55, 58, and then finally 90. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So this should be it. Okay, the C-scan. So you can see the difference from scan and also C-scan, especially at the part here when it's at the back of the track, at the end of the track. So get the difference between, okay, these two. We will get 50, 10, 24. Okay, 184 minus 18 is 166. 20, okay, 1, 16, 3, 90 minus 58, we get 32. Okay, so total up, you will get the total sick length. And the total is 322. Okay, if you want to get the average sick length, okay, you divide it by 9, you will get 35.8. Right, so this is the average sick length okay, for C-scan. So now you can compare all the performance of each of the this scheduling policies or algorithms. Okay, it's 5-4. Okay, you will get 55.3. Okay, seed length. Okay, when you mention about time, it should be short. Okay, meaning that the shorter the better. Okay, the shorter the better. So for SSTF, you get 27.5, scan 27.8, scan C-scan is 35.8. Okay, because the return time here, okay, the return time here is large. Okay, if the return time is not considered, it will get smaller. Okay, smaller and might be the smallest average seed length. All right. So basically, there are pros and cons for each of this scheduling. So I hope you can understand from the slides. Okay, you should see the performance. Okay, in terms of the throughput. Okay, in terms of the fairness, okay, response time, and so on. And you should be able to discuss why. Okay. So basically, okay, this is the one that I discussed just now, so you can refer to this. And we have come to the summary. So I/O architecture is the computer systems interface to the outside world. I/O functions are generally broken up into a number of layers, and a key aspect of I/O is the use of buffers that are controlled by I/O utilities rather than by application processes. Okay. So basically, buffering smooths out the differences between the speeds. Okay. The utility of buffering. Okay. It also decouples the actual I/O transfer from the address space of the application process. This I/O has the greatest impact on overall system performance. And the two most widely used approaches, okay, are disk scheduling and disk cache. Okay, the one that we covered just now is disk scheduling. And okay, we focus on 4 disk scheduling, which is 5-4, SSTF, scan, and C-scan. So a disk cache is a buffer usually kept in main memory that function as a cache of this block between this memory and the rest of main memory. Okay, so basically that's all for our lecture in input-output management and disk scheduling. Okay, I hope you can understand well from this lecture series. Okay, thank you very much. Assalamualaikum and have a good day.